Where is it increasing? Where is it decreasing? Okay. So like we read an English sentence, like I said in the warm-up, from left to right. From left to right, if it's going down, that's decreasing. If it's going up, increasing, then decreasing. So here we go. Let's describe the increase first. Okay, so on the increase, where I put the plus, I can see that the increase has a beginning point and an ending point. Notice. The increase starts somewhere and ends somewhere. Okay? It's not like the decrease. The decrease is coming from infinity, way up here. Right? It never started. It's never ending, and it's coming, it's decreasing, but it ends right here. It doesn't have a starting point and an ending point. It just has an ending point right here. But the increase starts here, ends here. So how can I describe all these x values is the question. Every x value from here to here, how would I describe that? That's the mission. So look at all these x values from here to right there. Right? These are all the x values that are on this increase part from here to here. It's greater than, so greater than -3, here we go. X is greater than -3. Because look at, all these values are greater than -3, right? All these x values. But we stop here, huh? The increase stops at, what value is that? 1, huh? So the x's also have to be less than 1. Not equal to 1, because at 1 there's no increase. It stops increasing at 1. So it's got to be everything less than 1, see? So x is two things at one time. X is greater than -3, that's all this, and less than -1, it's all this. So all this area, that's what describes the increased portion of the function. It's in between those two x values. So there's your increase. Now let's describe the decrease. Okay. So decrease, we're coming down from infinity, negative infinity, all the way down to -3. What's in common with all these x values? They're less than -3. So x is less than -3. But it's also greater than 1. Put and x is greater than 1. Since x is not in between two numbers, in all the decrease, I can't write it like the way I put on the increase, where x is in between a smaller and a bigger number. X is smaller than a smaller number, and x is bigger than a bigger number, so I write it this way, with the and in between. So x is less than -3, boom, it stops at -3, that's decreasing. Where else does it decrease? Well, everything greater than 1 is decreasing. We're rocking and rolling. Okay? Give me another x and y axis, por favor. Two more quick ones. Go ahead and plot a point at 3, 2. Let's make a simple parabola here. A simple parabola. This will be example 3, because we did 1 yesterday, 2 just right now. This is example 3. Give me a simple parabola. Give me a point at 1, 5. And 3, 3. So 4 points. Do those 4 points for me really quick. So -5, 1, 1 point there. -2, 2. Right, actually, -2, -2. 1, 5, then 3, 3. Do that for me. I'll wait. In case I was going too fast, example 3. X is less than 3 is an increase. Decrease is x is greater than 3. All right, watch this now. Look at this polynomial function. The degree is probably like 7 or something for the equation for this one, all wacky. We're coming up, coming down, coming up, coming down, up. Last one, grand finale. Make it curved too, not pointy. It's all curved. All right. So I'm going to highlight in blue the areas of increase. So this is increased. There's an increase. And there's an increase. 3 intervals, we call it. Intervals like a window. There's 3 windows of increase here, all in blue. Boom, boom. So let's describe the increase first. INC, the increase. Okay, so all the x's here are going to be less than a number, namely -5. X is less than -5, comma. So all this is x is less than -5, and now from here, look, we've got a starting point and an ending point there. That's where x is going to be sandwiched in between a smaller and a bigger number. X is bigger than, look at, x is bigger than, I'm going this way from -2. X is going to be bigger than -2, but less than 1, huh? X is going to be bigger than -2, look at greater than -2, but less than 1. That's this part. It started here and ends there. All those x values are bigger than -2. They're greater than -2, but less than +1. And then the last interval, anything bigger than +3. Those are all the windows where the function's increasing. Notice all that. And notice how whenever x is in between, when we have these two symbols, the two inequality symbols, whenever you have this situation, that's when you have a starting point and ending point. So look at the starting point is right here, ending point is actually right here. That's when you have x sandwiched in between a smaller and a bigger number. Make note of that. We'll put decreasing now in red. Decrease. So the function decreases from here to there. So look at, there's a starting point and ending point. So I already know that x will be in between two numbers here, from here to here. And then another starting point and ending point right here. Look at from here to here. Let's do it. Give it to me, Kasha. greater than negative 5 and less than negative 2. Beautiful. There's a first interval. So that's this part. Greater than negative 5 but less than negative 2 describes all the x values of this decreased area. So negative 5. Someone besides Castro, give me the other one. From here to here. X is what and what? I know it's going to be greater than something and less than something. What's the window? Help, help. And 1 and 3. X is greater than 1, less than 3. All right.